YouTube. Welcome to another session on dynamic programming DPV 6.5, pebbling a checkerboard. So in today's problem, we're going to be talking about a checkerboard that has 4 rows and n columns. We are given 2n pebbles and we must not exceed 2n pebbles, and given these 2n pebbles we must place 1 pebble in each square and maximize the sum of numbers, and no 2 pebbles can be vertically or horizontally adjacent. If you put a pebble in a square, either the one above, below, to the right, to the left, cannot have another pebble. You can have diagonal locations, but you cannot have adjacent ones to have pebble. Now, how many legal patterns are there? And then solve the problem to maximize the sum of numbers where you have placed the pebbles, and that is the problem. All right, so the number of configurations is 8, and the way you compute these configurations is that first configuration is just an empty config in any given column. And for the ones, you can put 1 in here, and the second, the third, the fourth. If you put 2 pebbles, you can only place them like this in a column, or like this, or like this. You cannot place 3 because then they would be adjacent. So any given columns config, there are only 8 possible configurations. Now, for this one, you can see that this kind of shows you the construction of the solution, that instead of having one single matrix, we designed 8 different matrices. And the way the 8 different matrices are designed, what you do is that you create a matrix, assuming if you're solving for the jth column, it's not just the j, but assume that there is another variable called k, and that k represents what is the last pattern. And the patterns were already described. We had 8 patterns, and if this first pattern, which was all empty, and the 8th pattern was, the certain 2 pebble pattern, so if that was the pattern on the jth, then that value here represents the maximum sum, assuming the kth pebble pattern was there in the jth column, and that is the value written here. Now, the key to the solution is that you have to understand that if this is known, then we can predict which ones are coming in the next column. Once again, if you know this value, if you know the maximum here, then you can compute all the values in the next column coming from here, from this one. If j was there, then you know how many patterns can follow here, and of these matrices, which ones would be a valid next step. You would know that. And given the rules, that adjacency rules that are provided in the problem, you know which one. So from that, you can say this is valid, and you can compute this value. And 0 is, or first pattern is compatible with all of them. So this would produce a value here, 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 all the way up to the bottom, right? And so you can write that down here. And then you proceed down this path. What if the second pattern was there in this jth column? If it was there, then you know that it's only compatible with 3, and therefore you would write another value here, another value here, another value here, and so on. And you walk down this all. And then you can compute the max that you get here. And that becomes this column's max, right? There's no point writing this overall max because it's only valid here. And so the way this problem works is that all you have to do is compute from all these previous locations, compute the possible feasible values here, which are reasonable, and then you compute the max for each matrix, and you compute and write down max for each. And then you move forward and you compute the next column, and so on. When you've computed all of these in the last column, you have to just find the max across all of these and put it up here, and this is your answer. This is the overall sum across all possible patterns that you could have put in that checkerboard. So that's it, and we can see that using dynamic programming, the order is n. You might say, why is it not n squared? You can see that on the y-axis, we compute only 8 patterns. It's not n. On the x-axis, you have n possible columns, and therefore we have solved the problem with dynamic programming approach in order and time. And that's it. And Hopefully you liked the solution, and if you did, please subscribe to my channel. I'll bring you more content on dynamic programming, and